Imagine a force, an invisible river of energy that flows all around us, through us, and even makes up the light from distant stars. This is the electromagnetic force. It's one of the four fundamental forces of nature, guiding everything from atoms to compasses. For centuries, we used it passively: light, warmth, magnetism, without truly commanding it. Now, we're harnessing this force not just for communication or power, but as a weapon. Electromagnetic weapons don't explode like traditional guns. Instead, they unleash bursts of pure energy. Railguns, for example, use magnetic fields to launch metal projectiles at incredible speeds. No gunpowder needed. Directed energy weapons, like lasers or high-powered microwaves, fire focused beams that can disable electronics or create intense heat from afar. These are weapons that use the universe's own language, forces and fields, to achieve their effects. At their core, electromagnetic weapons are a testament to our growing mastery of nature's most basic powers. We're taking the same force that creates auroras and focusing it for powerful, precise purposes. This is the dawn of a new chapter in humanity's story with technology. How do you build a machine that hurls metal faster than sound using only electricity? Let's break down the railgun. First, you need two parallel rails made of highly conductive metal, copper or aluminum. These rails form a channel for the projectile. Next, a massive power source, huge capacitor banks, stores and releases a surge of electricity in an instant. The projectile, often tungsten, is attached to an armature that bridges the rails, completing the circuit. When triggered, electricity races down one rail, across the armature, and up the other, creating a powerful magnetic field. This field generates the Lorentz force, which accelerates the projectile down the rails at hypersonic speeds. No explosives, just raw kinetic energy. In a split second, stored electrical energy becomes a thunderbolt of metal. The result? A weapon that's as much physics experiment as firepower. This is the essence of electromagnetic weapon design. Building a railgun requires a unique mix of materials. First, superb conductors, copper or aluminum for the rails, ensuring electricity flows freely. For the projectile, density and toughness matter. Tungsten is ideal, heavy, heat-resistant, and able to survive extreme acceleration. To power the launch, you need capacitors, devices that store and release energy in a flash. These use advanced ceramics or polymers as dielectrics to handle immense voltages. The structure itself must withstand colossal forces. Aerospace-grade composites and steel alloys keep everything intact during firing. Every component is chosen for strength, conductivity, or resilience. It's not just about exotic parts. It's about building a machine that can channel and survive the fury of unleashed electricity. The right materials turn raw physics into a practical, devastating tool. Each piece, from rails to frame, is critical to making the weapon work. The result, a device that's as much an engineering marvel as a weapon. Railguns are where advanced materials science meets the cutting edge of military technology. The challenge is not just power, but control. That's what makes electromagnetic weapons so revolutionary. Electromagnetic weapon technology isn't just for destruction. It could transform our world for the better. The same principles behind railguns could launch satellites or cargo into orbit, making space access cheaper and safer. Directed energy systems, like microwave beams, offer non-lethal crowd control, dispersing riots without bullets or lasting harm. Research into these weapons drives advances in energy storage, materials, and wireless power, benefiting electric vehicles, infrastructure, and more. The pursuit of powerful tools often leads to breakthroughs that ripple across society. Like fire, electromagnetism is neutral. Its impact depends on how we use it. A railgun can be a weapon, or a launch pad to the stars. The real potential lies in our choices and creativity. Technology's value is shaped by our wisdom. The challenge: use this new power responsibly. Every leap in technology brings both promise and peril. Electromagnetic weapons could make warfare less explosive. No chemical munitions, fewer catastrophic accidents. Their speed and precision offer powerful deterrence and defense, potentially making attacks riskier and less likely. Directed energy weapons could shield against missiles and drones, shifting the balance toward protection. But these advances could also spark a new arms race, destabilizing global security. Faster weapons mean less time for leaders to make decisions, raising the risk of mistakes. As these technologies spread, the threat of misuse grows. Critical infrastructure could be targeted with devastating effect. The unknowns are vast, the stakes enormous. Electromagnetic force offers both a path to progress and the risk of destruction. The future depends on how we choose to wield this power. The responsibility is ours.